In this video, we're going to work on naming and drawing amides. Here's an example of an amide. If you pause the video and try to name it, come back and I will go through the process of naming this molecule. Okay, so this molecule is an amide, and I'm going to first show you how I know that, because what's always best when naming a molecule is determine the family name. I see here a carbonyl group, and when I see a carbonyl group, that kind of defines a little bit what family it's going to come from. On one side of that carbonyl group, I see an R group. On the other side of that group, I see a nitrogen, and then attached to that are two groups. This group here and this group here. And so this has a general structure of R attached to a carbonyl, attached to a nitrogen, which is attached to two other things. That's the general structure of an amide. So I know in front of me that I'm going to have to name this as an amide because that's what I have. I'm going to erase all these little marks to get back to our original molecule. And since I know this is now the family of an amide, I know that the name is going to end in amide. The next thing I need to do is figure out the parent name of this molecule. When I determine the parent group, I always start with the carbonyl carbon, just as you would do with other carbonyl containing molecules. So the carbonyl carbon, what I want to find is the longest continuous carbon chain that contains the carbonyl carbon. The carbonyl carbon gets the lowest number possible. In an amide, it will always be the one carbon. And in this molecule, I can see that I have a second carbon and a third carbon. So I have a 3-carbon chain here, and so this is a propane derivative. When naming and adding the parent name to an amide, I drop the E and add the parent name, which in this case is propan. And so this is a propanamide. Now I go ahead and name the rest of the molecule kind of like as substituents. I look on the nitrogen at this point, and I see a group here, and I see a group here. If it's just an H, it's understood to be there, and so we don't have to name it as a substituent, just as you would like an alkane. If you had a hydrogen sitting on a carbon, you don't name that hydrogen. But I do see a group hanging on the nitrogen on another bond, and this is an ethyl group. And so the way we write this in nomenclature, because it's attached to a nitrogen, I just put the letter N and the group attached to it. And so this molecule is called N-ethylpropanamide. Okay, here's another molecule to attempt to name. Take a few moments and try to name this molecule, and then come back to the video, restart it, and I will go through the naming of this molecule. Okay, so once again, I see that we have an amide on our hands because we have this R group, which is attached to the carbonyl group, and then I have a nitrogen out here. And so it has the general structure of R attached to a carbonyl, attached to a nitrogen, which is attached to two other things. And so this is an amide. Let me erase all those marks, and then we'll go ahead and name this as an amide because it comes from, and I'm going to name it as an amide. Amides have the suffix or the family name of amide. So that's nice and straightforward for us. The next thing I need to do is determine the parent name of this molecule. The parent name is going to come from the longest continuous carbon chain that includes the carbon of the carbonyl group. And so I just numbered the carbon of the carbonyl group as number 1 because the carbon of the carbonyl group must get the lowest number possible. And in this case, and in all cases of amides, it's going to be the number 1 carbon. And so I see carbon 2, carbon 3, and carbon 4. And so this is going to be a butane derivative. When we name amides, we take that and we just lop off the E and add the rest of it in front of amide. And so this is a butanamide. Now I name the rest of the molecule as substituents on the N, or the nitrogen. I see a group here and I see a group here attached to the nitrogen. They're both methyl groups. They're both attached to nitrogen. And so in amide nomenclature, whatever's attached to the nitrogen, you just put the letter N. Because I have 2 methyl groups, I need 2 N's, just indicating that there's going to be, each of them are attached to a separate spot on nitrogen. And it's going to be di because there's 2 methyl groups, and so it's dimethyl. And so the proper name of this molecule is N N-dimethylbutanamide. Okay, now we'll flip the tables and we'll try drawing the molecule from the name. So I've given you a name here. If you pause the video, come back in a few moments and then I'll go through the mental process by which you would draw this molecule. Okay, when I draw a molecule, I always basically start on the right-hand side of the name and work my way left. I just find it easier to do. And so therefore, if I'm starting on the right-hand side, I'm looking for the family name, which I just underlined. And so based on this name, I can tell it's an amide. And amides have a general structure of a carbon attached, double bonded to an oxygen, attached to a nitrogen, which is attached to 2 things. And the carbon of the carbonyl is also attached to some R group. So now I need to move a little bit further left to figure out what's attached to that. And I see I have a hexane, parent name, which means it's 6-carbon chain. This chain must include the carbonyl carbon, and the carbonyl carbon gets the lowest number possible. And so that's carbon 1 is the carbonyl carbon, and so therefore I need 5 more carbons in my chain. That's 4, 5, and 6. So there's my 6-carbon chain. And then I keep working my way left to see if there's any substituents, and I see one, N-isopropyl, which means this substituent is hanging on the nitrogen, and so it doesn't matter which spot I put it in. I can go ahead and add an isopropyl group to one of the nitrogen bonds, and so I just pick this one. And then because there's no other substituent in the name, the other bond to nitrogen is a hydrogen. So now I just need to go back to the chain over on the left here, the 6-carbon chain, and just because there's no other group, I just need to decorate it with hydrogens, and I will be done drawing this molecule. So there is the proper structure for N-isopropylhexanamide. So we'll try one more drawing of a molecule. There's a molecule name, 3-bromobutanamide. Pause the video, try to draw that structure, then come back and we'll go through the proper drawing of this structure. Okay, when I draw a structure, I always start on the right-hand side of the name and start with the family name. In this case, it's an amide. Amides have the same general structure. Carbon double bonded to an oxygen. That carbon is also attached to a nitrogen. 2 things are attached to that nitrogen, and we won't know till we get to the name of what that is. And then the carbon's also attached to an R group. So there's the general structure. Now we just need to fill in the remaining bonds, and we'll get to that when we get back to the name. The next part is the parent name. It's a butane, which means it's a butane derivative, which is a 4-carbon chain. The parent name also always includes in that chain of carbons the carbonyl carbon, and the carbonyl carbon always gets carbon number 1. There's carbon 2, carbon 3, and carbon 4. There's my 4-carbon chain where the butane came from. And then I got to see if there's any substituents, and I go back to the name, and I see on the 3rd carbon that there's a bromo group. I can tell it's part of that carbon chain that I just did because it doesn't have the N letter in front of it. If it was N-bromo, it would mean the nitrogen's attached to a bromo directly, but in this case it's not. It's 3-bromo, so I put a bromo on the 3rd carbon, and there's no other substituent in this molecule, so the rest of the molecule is decorated in hydrogens. And so I can go around and add all the hydrogens on to this molecule. And there's the proper structure for 3-bromobutanamide.